problem 658, find k closest elements. Uh, we'll go through the question here. So, given a sorted integer array and two integer k and x, return k closest integer to x in the array. The result should also be sorted in ascending order. Okay, so an integer a is closer to x than an integer b if the absolute difference of a and x and b is smaller than b and x, or in case if both of them are equal, then the element a should be smaller than b. Let me explain you by giving this example, which is example 1. Suppose the array is 1 2 3 4 5 in this case, and the element is 3, so we need to find 4 closest element to 3. In this case, 2 3 4 are the obvious choices as the element itself is 3. But now we have already 3. So in between 1 and 5, in order to consider, we need to consider only one of them because we have already 3 closest element. So we will choose 1 in this case because, as highlighted section says, that if the absolute difference is same, then we are going to consider the smallest element. And in case if the element doesn't exist, so uh, like -1, it doesn't exist in this array, but it is closest to 1 2 3 and 4. So we are going to return that. So the biggest sin that is given in this question is the array sorted, and the first thing that comes to my mind is we are going to use a binary search. Uh, by the term binary search, I mean to say that what I'm going to do is going to search whether this element exists in the array or not. So or the closest element to that. So first, I'm going to uh, find the index of the x value provided, and then once I have the index, now what I can do in this case is I'm going to uh, compare left and right element of that particular value, and uh, do a sliding window on that. And once my sliding window size is equal to k, then I'll stop my condition, I'll stop my loop, and I'm going to return the value by iterating left to right. So that is the approach that I can think of, and I hope you were able to understand this approach. So the time complexity that I can think in this case will be for finding the index of the value, index of x, we are going to use log n, and in order to find k closest element, we are going to iterate k times. So it will be log n plus k, and uh, let's code it out. So, yep. Let's go to code and start working. So we are going to take a list of integer, and let's name it as result. I'm bad with naming conventions, so never mind. And we'll take a array list. So what should be the base case? Suppose if the number of element in the array as given in the constraint says that it can be equal to k. So if it is equal to k, then what we are going to do is we are going to return all the elements that are present in the array right away by storing it in the result. So we are going to traverse it uh, int val, and uh, we are going to traverse through all the element of array. We are going to store it in the result, which is this, and we'll return the result. This should be our base case. So yeah, step 1 is done at least. We'll move forward. Why this was complaining? Okay, so yeah, base case is done. This was our base case, that in case if it is this, then what we need to do is to really find whether x exists in our array or not. So what we are going to do is to find x closest index, and from there we can do a sliding window and get the closest element to that. So what we are going to do is we'll simply do a simple binary search. In this case, it will be right equals to array length -1. Sorry for the delay. I'll try to speed it up. And so what I'm going to do over here is I'm going to compute mid and check the overflow state, overflow of integer condition, that it should not overflow if it is if the length is equal to the integer max value. That's why we have done that. And if array of mid is a higher than, so what we are going to do is if array of mid is higher than or equal to the given value, then in that case it'll lie either on the, so the mid right index, the right boundary is going to come to mid, and else if it is not the case, then left will be equals to mid plus 1. Okay, so this condition is going to break once left is equal to right, and once we have found the array or the closest element. So in order to create what I can say, in order to create a sliding window, what we are going to do is we'll define a window something like this. In our window, we are going to consider the current element that is there. So what we are going to do is, in order to handle the boundaries safely, we are going to do is left equals to left minus 1 and right will be equals to left plus 1. So currently how it is going to look like is, if we consider 1 comma 2 comma 3 4 and 5, and if we are searching for x element, then my left is on 2 and my right is on 3. So currently why I have done that, because in order to handle the boundary condition efficiently, else we had to write too many ifs and else condition, and that would have been very trickier. So now what we are going to do is we are going to iterate till I have my window size -1, obviously, because I have taken a condition that uh, like if you do 3 minus 2 and -1, currently I don't have any element in my uh, sliding window. So that's why I've done -1 to uh, reduce that. And what I'm going to do is, if my left is, so let's handle one by one. So if my left is already on, left is equals to -1, in that case what I'm going to do is I'm going to increase my right boundary and I'm going to continue, because I've already incremented it by 1 and I need to check the condition again. If right is on the boundary, so if right is array.length or math dot abs of array of left minus, so whatever is smaller uh, or equal, in case if they are duplicates, so we are using equal. And if we see math dot abs of array of right minus x, and let me just expand it properly. So in this case what we are going to do is we are going to widen the window size, else what we are going to do is we are going to increase the right boundary. So at the end, this loop is going to end once we have k closest element. And now it is a simple thing that we need it in a sorted fashion, right? So we are going to traverse from left to right, and all the elements from left to right is a part of already sorted array. So left to right will be automatically sorted. So int of left equals to int of I equals to left plus 1. And as we have taken extra padding over here, we are just removing it while taking things into consideration. And I plus plus, and what we are doing over here is result dot add of array of I, and we have stored successfully all the elements, and we'll be returning this result. And let's run, and yep, we have a working solution. So uh, we can analyze the time complexity. Here we are going through in worst case, it'll go up to k if the array length size is equal to k. Else we are going to find the particular index of the element, and it is going to take log n. And for checking the k closest element, we are going to use the two pointers and move till k element, at most k element, so plus k. So log n plus k will be the final time complexity, and space complexity is obviously of 1. Thank you. I hope